Greetings and welcome to lesson 2.7, page 84 in your Big Ideas book. Ladies and gentlemen, this is the last lesson of Unit 2 on transformations. And yes, we are going to finally do our fourth and final transformation, one that you have not probably done before. This one is called a dilation. We are going to apply what we learned to, one, identify these dilations. And then we're going to use something called scale factor to enlarge and reduce figures in a coordinate plane. Our essential question, how can you enlarge and reduce a figure in the coordinate plane? And because I know that you have read page 84 and 85, you've taken notes, you are a person of character, a person of intelligence, you already understand that when we dilate something, we are making it larger, we are making it smaller. Some of you who have been to the eye doctor before, you may have had your eye and your pupil in your eye dilated. That's making it larger so that the doctor can see in there better. You will notice that your eyes dilate based on how much light is available. If you are walking in a dark room, your pupils will be dilated very large to allow in as much light as possible to see. If you walk out in the sun, your pupil will get really small because it does not like all that light. Ladies and gentlemen, a dilation, of course, is our fourth transformation, in which the figure is either made larger or smaller in respect to a point that we call the center of dilation. Now, if you look at your picture that I provided for you, you can see that you have two figures, and this is important to notice. When you draw a line through the corresponding points of the figure and the image, you will notice that they also pass through, or they come together at the center of dilation. So if we were to take these two others, like say this point right here and this point right there, and we were to draw another line, it would go right through those. Same as it would if we chose these other 2 points up here and up here. You can test it with a straight edge if you want to. Ladies and gentlemen, there is something that is not talked about until the bottom of this page that you will most likely put down in the second video notes. But I want to mention it here because I think it's important. And that is that the image and the figure are similar. That's why we learned all about similar figures in the last couple of lessons before we're doing this dilation. So we create a similar figure when we make it larger and when we make it smaller. So, ladies and gentlemen, let's take a look at identifying similar figures. Now, hopefully, you understood what I said when I talked about if you draw a line through corresponding parts of the image and the figure, that they will pass through what you call the center of dilation. Now, when we look at this and it says, hey, we're going to identify a dilation and tell whether the blue figure is a dilation of the red figure. So first of all, this one is the red and this one is the blue. So it's asking, is blue a dilation of the red? So we can see that the blue figure is smaller, so this one would actually be a reduction, a dilation in which the figure is made smaller, if this is in fact a dilation. And we're looking and we do not see what we would call a center of dilation. So what you need to do is when you're done, or when I'm done with this example, you need to pick up your straight edge and draw it for yourself. But I'm looking at these two corresponding parts right here. These two parts right here on the red and the blue. And I'm going to draw a line through them. And then I go to these two corresponding parts on the other part of the triangle. And I'm going to draw a line through that. And then if I go to the third of these triangles, corresponding parts, and I draw a line through that. Oops, I can't draw very straight when I'm here. But that would technically go right through all three of them. Now we have all three where there are lines drawn through corresponding parts and they all pass through the same point. That would be the center of dilation. And since they all do that, yes, 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 this is a dilation. And yes, the blue is a reduction of the red figure in this particular example. Go ahead and pause and meet me for example number 2. Here in example number 2, again, we're going to tell whether the non-shaded figure is a dilation of the shaded figure. And you can see that the shaded figure is on the inside and the non-shaded figure is on the outside. So in this particular case, if in fact the non-shaded figure is a dilation, it would be an enlargement because the non-shaded figure is larger. And once again, what we want to do is we want to draw a line through corresponding parts. And so I'm going to change my color here, red, for these two corresponding parts. And if I draw a line through that, voila. Then I go to 2 other corresponding parts and I draw a line through that, voila. And then I do my last point and corresponding parts, I draw a line through that, voila. And again, because I don't have a straight edge capability on this video, I'm kind of doing it by hand. But as you can see, yes, in fact, they all go through a center of dilation. They all meet right here in the center. In fact, the center of dilation, in this case, is the origin of this coordinate plane. It is, it is. So yes, the non-shaded figure is a dilation of the shaded figure, and it is an enlargement because it is bigger. So go ahead and test it out for yourself and then meet me for example number 3. So now in example number 3, when we tell whether the dashed figure is a dilation of the solid figure, the first thing we're going to say to ourselves is, well, they look exactly the same size. If I'm going to make something larger or smaller, then the dilation can't exist if they're exactly the same size. So we already are recognizing that no, this is not. And to prove it, if you were to take and draw a line through corresponding parts, if I drew a line through that point of the arrow, and then I go to the top of the arrow and draw a line, and then I go to the bottom of the arrow and draw yet another line, I would see that those lines are all parallel. They are parallel, so this would be no. This is not a dilation. Not a dilation. So, ladies and gentlemen, I did mispronounce that. And it's easy to do. This is called a dilation. And for some reason, we have a tendency to say dilation, and it's not. It's really dilation. So, ladies and gentlemen, your first quick write of the night. Tell whether the shaded figure is a dilation of the non-shaded figure. I gave you copies of these to put in your notes. You can finish your quick write. When you do, have a quick snack, a quick break, talk to your mama about what you're learning, and come back and see me for video number 2.